Hi friends, welcome back to my new video. Today we are going to discuss about a thermal power plant. Basically the power plants are the components which are used for generating an electricity. There are various types of power plants like a hydroelectric power plant, thermal power plant, nuclear power plant, gas turbine power plant and diesel power plant. Today we are going to discuss about a thermal power plant in which basically we are going to have a turbine, generator. These are the devices. So let us see what is a thermal power plant. In the thermal power plant, basically there are 4 to 5 main components. First component is the boiler. So this is first component. Then next is the turbine. Then third one is the generator. Fourth one is the condenser, and fifth one is the feed water pump. These are the major component in the thermal power plant. Okay. So by combination of all these, we are going to generate an electricity. Okay. So let's see the function of each component. Here, what's meant by boiler? First of all, we will check it. Boiler is a device which will generate pressurized steam. So input for the boiler will be water and output from the boiler will be water. Output from the boiler will be a high pressurized steam. So if you check out this particular boiler, in the boiler there are two connections basically for the water. So this particular connection is for taking water inside. So water will be going inside and it will be flowing through the tubes as like this, and then that will come outside from this particular pipeline. Okay, so when the tube is inside the tube, we are having a water and it's flowing. There will be a hot gases generated by this particular combustion chamber. So in the boiler there is a combustion chamber in which the fuel will be burned. The fuel may be a solid fuel, liquid fuel or gaseous fuel. In the solid fuel generally coal is used. In the liquid fuel diesel, petrol will be used, whereas in the gaseous fuel LPG may be used. Currently in the figure whatever you are observing is the coal. So we are using the coal as a fuel, and by using coal we are generating the heat. So here the device is called as coal hopper, through which we are going to supply the coal. That coal will be go downside into the pulverizer. What happens in a pulverizer? In the pulverizer there will be a conversion of a solid coal into the powder form of the coal. So here the powder will be generated and that powder will be supplied further to the burner. So for burning of the coal, what we require is the air or oxygen. So that air will be supplied through this one and that coal will be burned and will be generated high heat inside a boiler. Now as we have discussed, inside the tube we are having a water and outside the tube we are having hot gases. So heat will be transferred from hot gases to the water, and the water will get converted into the steam, and that steam will be at very high pressure. So at the inlet of this particular we were having the water here, and at the outlet we are present having what? A steam. So steam will be present and that steam will be a very high pressurized steam. That steam will go to the turbine. Now what is turbine? Turbine is a device which will generate a mechanical energy as an output. There are various types of turbine available like a hydraulic turbine, gas turbine, steam turbine, etc. These are the type, depend upon what energy you are giving as an input. If you are giving input as a water, then it's called as hydraulic turbine. If we are giving input as a gas, then it's called as gas turbine, and if you are giving input as a steam, then it's called as steam turbine. Currently we are giving steam as input, and that's why this particular turbine is called as steam turbine, which will generate mechanical energy. Now next component is the condenser. The condenser is a device which will convert steam into the water. So their condensation process will be occurring. So here at the input there will be steam and output will be water. Then this is the feed water. Feed water pump has a function of taking water from one side and supplying water on a further side. So here we are discuss about major component, that's boiler, turbine, condenser, feed water pump. Okay, so now we will discuss one by one how the mechanical energy generated and how the electrical energy will be generated. Okay, so as I told you, in the boiler there will be water will be taken inside and steam will be present outside. That steam will go inside a turbine. Inside turbine what happen? Here if you check out this particular turbine, inside turbine the steam will be coming from this side, and inside turbine we are having a blades, and that blade will be connected to one common shaft. So that steam will come from this and it will give impact on the blade. So blade will start rotating. As the blade start rotating, the shaft start rotating. As the shaft start rotating, we will be having mechanical energy available here. So at the output of the turbine, what we are having is the mechanical energy. Now this mechanical energy is connected to generator. The generator is a device which will take mechanical energy as an input and give output as an electrical energy. So here we are showing that electrical energy will be available. So mechanical energy is input and output is electrical energy. Now whatever steam used for generating and mechanical energy, after giving impact, its pressure will be less, and that less pressure steam will further supply to the condenser. In the condenser, what we are doing, in the condenser we are cooling that particular steam by using what? A cold water which is coming from a cooling tower. So steam will be coming from this one and that will be cold, and after cooling we are having the water. So at the inlet there is a steam, and here what we are having is the water. So for converting steam into water, we have used the cooling tower. From the cooling tower we will be supplying the cold water from this side. So here that will supply cold water. Cold water will be inside the pipeline which will used to cool the steam, means heat will be flowing from steam to the water, and that's effect of that the water will be get heated and we will be having a hot water at the outlet. So at the outlet from this particular condenser we will be getting hot water. So that hot water will go to the cooling tower. Cooling tower cools it, once again cold water will be coming. So this is complete cycle, that water goes to the condenser, it will be get heated, water goes to the cooling tower, it will be get cooled. So this cycle will go on repeating. Okay, now the steam which has gone to the condenser, that will come outside as a water. That water will be get sucked by the feed water pump, and then that water will be supplied to a boiler. So this is cycle gets completed, that boiler supplies the steam to the turbine, turbine supplies steam to the condenser, condenser supplies water, and that water will be taken by feed water pump and it is supplied to the boiler. Now sometime what happen, the steam which is generated, that steam will get leak, means the amount of the steam will get reduced, and that's why what happen, we have to supply the makeup water. Makeup water means what? If we are supplying here 100 kg of the steam, that 100 kg may not be available here. Here it may be having something 98 kg. So where 2 kg of the steam gone? It's through the leakage in the turbine and various pipeline. So we cannot supply 98 forward, because if I supply 98, then next cycle this 98 will become 96, then 94, then 90, like that. So we have to supply 2 kg of the water through the water source. So 2 kg will be used as a makeup water, and finally we will be getting 100 kg of water as we are doing for the further cycle. Okay, so this is what a feed water or makeup water that we are supplying from this. So this is a working of a thermal power plant. In the thermal power plant we were having the aim of generating electrical energy, and that electrical energy is available from the generator. Okay, and further component like boiler, turbine, condenser and other component are used for generating mechanical energy. That mechanical energy is given to generator, and generator will generate the electrical energy. So this is all about working of